So here's the last of our examples, probably the craziest one. You notice that, first off, you have three fractions here. In addition to that, I also went back to one of our previous chapters with inequalities. You have to be able to work with that. When you run into an inequality, I favor the method that I'm teaching you for the reason that you don't mess up the direction of your inequality. If you're cross multiplying, if I had just one fraction equal one fraction, I have to go bottom times top, and that result has to be here. Bottom times top, that result has to be here. So if you do that cross multiplication, it's very easy to get the inequality going the wrong direction if you don't multiply bottom times top. And then for this particular example, I have the three fractions, so you can't do that. And so I like to teach that method that's universal. It will get you out of almost any jam. When you see all those fractions, that's our motto. We kill the fraction. We get rid of it by multiplying by the common denominator. In this case, it would be 3 times 5 is 15. 15 times 4 is 60. So I'd multiply by 60. Or if you prefer, you could write them all out on the side here. You can go 3 times 5 times 4. I'll show you what I'm talking about here. And so as I distribute this to the first fraction, the 3's would drop out, because that's top and that's bottom, and that would leave me with 20 times, now x plus 1 comes down unchanged. As I move to the second fraction, the 5 would drop out, so if that drops out, I have 3 times 4, which is 12. I have to pay attention to the sign. I'm going to say minus 3 times 4 is 12. Numerators always come down unchanged, so it's 2x plus 4 greater than or equal to, and for this last fraction, as I distribute all the way over, the 4's would drop out. If the 4's drop out, 3 times 5 is 15, and this numerator comes down as x minus 4. Now I have an inequality to work with. Kind of an exciting one, at least from my perspective. You may not think so. And so I get to distribute here. Boom, boom. That gives me 20x plus 20. I distribute my negative 12. This is one of those things we continue to struggle with. Pay attention to your signs. Negative 12 times 2 is negative 24x. Negative 12 times 4. Can't do it in your head? Use your calculator. Negative 48. Greater than or equal to, and I'm going to distribute here. 15 times x is 15x. 15 times negative 4 is negative 60. And like always, kiss the problem. Keep it simple, silly. Combine those like terms. 20x, take away 24x is a negative 4x. 20 and negative 48 would be negative 28. Greater than or equal to 15x, take away 60. As always, our motto is to pick on the little guy. So when we look at this negative 4x here, where that's screaming at us that it's smaller than the 15x, we want to move that over to the left-hand side. That means that this negative 60 will move over to the right. I write the original term, negative 28. Negative 60 comes over as positive 60. Greater than or equal to 15x plus 4x. Combine some like terms here and see where we're at. We have positive 32. 60 take away 28 is positive 32. Greater than or equal to 15x plus 4x is 19x. Now I divide by 19. I divide by 19. And that would be, what here? 1 and 13/19. My pause there was because I'm using an older calculator. I'll scoot this over here. I don't know if you all can see that. My fraction to decimal button on here doesn't work. If I get extreme fractions, you see it just keeps coming up the same way. And so, as I always tell you guys, I'm old school. Old school, that's the way we did it. We see that 19 goes in there once, and I just count up. 20 to 32 is 12, plus the one from there is 13. So I have 1 and 13/19. Because this was an inequality, You know that you have to use that set building notation. We would say the set x such that x, as I look at this, I notice that it's pointing at the variable. It points at the variable, so it still needs to point at the variable here. And this represents there's a ton of answers that would actually solve this. Remember our number line, put a 0 on there, locate 1 and 13/19. Decide that that would be a closed circle, and that would shade off to the left, representing that there's more than one answer. There's an infinite number of values that will make the original inequality work, the original statement true. This is something you're going to see down the road, and this is why I teach it. The whole reason for this example is to show you that if I have 3 fractions, that's not going to scare me. It never changes my method. I always take the common denominator, I distribute it out. I'm not a fan of cross multiplication. I don't think it's a universal idea. It only works when you have one fraction equaling one fraction, and so I encourage all of you to use this method here where we multiply by the common denominator. Here are 7 examples for multiplying with a common denominator to solve proportions or proportion-like problems. Today, the homework will be very much like what you see here. Tomorrow we'll get into applications where you have to read the word problem, set up a proportion, and we'll have additional notes for that. We'll see you tomorrow.